Hello, hello, hello! My name is Patrick James Yurish. I'm an integrative health practitioner up in Northeastern Pennsylvania, and today I'd like to bring you tying in something in our gene code and the Bible. So, today's discussion will be on the GULO gene, G-U-L-O, the GULO gene. What is the GULO gene? So, the GULO gene, standing for gulonolactone oxidase, produces the last of four enzymes in our body required to convert blood sugar, whether that be dietary sugar, whether that be sugar that our body just makes, blood sugar, into vitamin C. However, it no longer does. So, why not? There is actually a point mutation or a nonsense mutation on the GULO gene. So think about the gene. We have a DNA ladder, a double helix, a spiraled up ladder, and this is what genes are made of, DNA. And we have on the ladder rungs on the DNA ladder, and this is what's called nucleotides. We know adenine, thymine, guanine, cytosine. Don't get confused, they're just letters, they're just A, C, T, G, just rungs on the ladder. Now, when these are in a certain configuration on a DNA ladder, they signal the gene to start making an enzyme, start making a protein. This is called a start codon. Now, normal genes, functional genes, have a healthy, normal stop codon, just a specific configuration of nucleotides that say stop making the enzyme, stop making the protein. Now here's the problem with our GULO gene. It has a premature stop codon. It has a premature configuration of nucleotides signifying to stop making the enzyme before it's completed. Now, we don't have a complete enzyme. We don't have a complete gulonolactone oxidase enzyme in our body to convert the blood sugar to vitamin C. Now, here's the thing. We don't have this. Most mammals do. Most mammals convert blood sugar to vitamin C in their liver or in their kidneys. Now, why don't we have it? We don't have it. Some primates don't. Fruit bats don't. Guinea pigs don't. We don't. So why don't we have it? Well, if you look at every individual right now, every human on the planet, we all have the same mutation. We all have a point mutation or a nonsense mutation right on that gene. So how is this possible? How does everyone we see have the same mutation, the same point mutation? Well, there had to be a giant bottleneck in human history. There had to be a time period in history where all of humanity funneled up into a couple people. Where did this happen? Well, from an evolutionary perspective, they don't really know how this occurred, when did this happen, how could it happen. However, the Holy Scriptures give us an answer, give us a time period where this bottleneck happened, and we know this as Noah's flood. Noah, his wife, his 3 sons, and their wives, all aboard on the ark. The rest of the earth was flooded with water. There's your bottleneck. There's your time period in history where all of humanity got funneled down into 8 people. So either Noah or one of his children must have had the gene mutation and then passed it along to everyone else, and now we all have the same mutation. And this is what we actually would predict to see when it comes to a gene mutation, is you go from great lifespans, great length of years, to tapering down to fewer years, until you get to, we know, 120 years, 70 years, 80 years if by reason of strength, but we don't see the 900 some years anymore. Why? Well, one big reason, I believe, is because we're not making vitamin C anymore. I believe the biblical patriarchs, the men in Genesis, lived great lifespans. One big reason why is because they're producing vitamin C 24/7, 7 days a week, 365 days a year, and more under stress. So, we look at the animal kingdom. We look at mammals, for example, that produce their own vitamin C. First off, they don't get heart attacks like humans do. They do not get heart attacks like humans do. Mammals that produce their own vitamin C do not get blood clot heart attacks. There was a man by the name of Matthias Rath actually wrote a book called Animals Don't Get Heart Attacks, but People Do. The man deserves a Nobel Prize, but he goes unrecognized. So he pretty much concluded within his research that animals do not get blood clot heart attacks. People do. Why is this? Well, one big reason is where do our arteries, where do our blood vessels withstand the most wear and tear? Well, of course, by our heart. It's constantly pumping 24/7, and they're really sustaining a lot of wear and tear. So with this degradation, with this wear, there's a little protein called LPA, lipoprotein A, that comes to the blood vessel and makes reparative work on the vessel. Now, here's what happens. The LPA, or the lipoprotein A, is very sticky. So yes, it makes reparative work. Wonderful, amazing. However, when we have too much LPA, what happens is blood cells will pass by and get stuck. And now you have a clot on your hands. So where does vitamin C come into play? Where does vitamin C remedy this problem that's occurring within humans and not in mammals? Well, what's going on here is vitamin C not only will regulate lipoprotein A levels, but it will also strengthen blood vessels. Vitamin C strengthens blood vessels. Some theorize that LPA is actually taking the spot where vitamin C should have been. Vitamin C is strengthening your arterial walls, strengthening your veins, strengthening your capillaries. It's strengthening your blood vessels to prevent the need for LPA to even begin with. And now you don't really need much reparative work from lipoprotein A because vitamin C's strengthening your blood vessels where your heart is pumping. So this is why we do not see heart attacks, specifically the blood clot heart attacks, appearing within the animal kingdom, the mammals that produce vitamin C. So vitamin C is absolutely extraordinary for health. Another thing is, when our cells breathe oxygen, it's called cellular respiration. They let off tiny little free radicals, oxygen-derived free radicals that are toxic. They're missing an electron. So they go around and steal electrons from cells and tissues, called oxidative damage, and in doing so damages cells and tissues. So vitamin C is an electron donor. You take vitamin C, it donates one of its electrons to the free radicals and quells the free radicals, makes them stable. They no longer go around stealing electrons, damaging all your cells and tissues. And we're hit by so many free radical bullets every single day. Vitamin C quells this oxidative stress, which is a major driving factor within the aging process. So I believe a huge factor for the health span, most likely, and the lifespan we see within the biblical men that are in Genesis is because one huge reason, they produced vitamin C internally. So how can we kind of remedy this problem of hypoascorbemia, lack of vitamin C? Well, first off, I would say, in my opinion, that the recommended daily allowance is actually set forth to prevent deficiency diseases, which is good. It's great. Awesome. The issue with that is it's not for optimal health. It's just to prevent deficiency diseases. So when we look at the animal kingdom, for example, we see a mature goat around the size of a adult human produce about 13,000 milligrams of vitamin C per day and more in distress. That's a little more than the set forth amount that we see as around maybe 60, 90, somewhere around there milligrams per day. It's a little more. It's a lot more. Doesn't harm the goat. Doesn't hinder the goat's health. It actually helps the goat's health. So when we compare other mammals that produce vitamin C, we, and Bill Sardi came to the conclusion, and other people in this field came to the conclusion that about 40 milligrams per kilogram, or 2.2 pounds of body weight, is the minimum for optimal health. So what would this look like? A 145-pound individual would need around 2,500 or around 2,600 milligrams per day of vitamin C for optimal health. And I believe from my research, this is correct. This is what I recommend. It's very simple and easy for people to do. A quarter teaspoon of vitamin C in powder is 1,000 milligrams already, or you could buy 1,000 milligram pills, and you're totally fine in that route. So vitamin C supplementation, it's amazing for your health. It's amazing for your immune system. We have kind of a blank slate cell within our body called stem cells. They could differentiate into other cells of the body, and stem cells with sufficient vitamin C mature into T cells. What are T cells? T cells are your memory immunity. That's what T cells are. T cells are providing your body with memory immunity to fight specific infections. And your stem cells mature into that with vitamin C, mature into T cells with vitamin C. So please, everyone, I recommend take vitamin C. It's amazing for blood flow. It's amazing for immunity. It would help everyone out to take vitamin C. So thanks so much, guys, for listening. If anyone would like to reach out and learn a little bit more about myself, my website is Yurish IHP.com. That's YURISHIHP.com. Thank you so much. God bless.